Hello, students. 大家好. This video is to go through some important experiment with you all for your SPM chemistry paper 3 AMALI tomorrow. So I believe everybody got tips, some tips from people around you, your friends maybe from Telegram, from your school teacher. Okay, we know that most likely heat of neutralization is going to come out, but nobody actually knows that what was the exact question lah. Okay, so everybody trying to do a ramalan and predict the question that's going to come out tomorrow. So here, say I have selected some experiment, selected a few questions to go through with you in this video today. So first, before we go through the experiment, we have to understand a little bit about the concept about heat of neutralization. So in the heat of neutralization experiment, it is mainly about neutralization. So it will always involve an acid and a base or alkaline. So the reaction between acid and the base is going to produce water. Whenever water is produced, there will be heat energy released to the surrounding. So that means neutralization is always an exothermic reaction. So when we're doing this experiment, the result that we want to obtain is actually the final result we want to obtain is like how much energy is released during the reaction. So you got to take the temperature and see, and then you calculate the heat energy release. And here are some things that can manipulate, they can change, and make it into different experiments. So this is why I have predicted a few different experiments. So they can change the volume and concentration of your reactant. They can ask you to repeat the experiment with different volume, with different concentration. And this will result in a different amount of heat release. Okay, so if there are more reactant, you get to the reactant, then there will be more heat energy release. Okay, just like that. If lesser reactant, lesser heat energy release. They can also change the type of reactant they use, and this results in a different heat of neutralization. If you are using a strong acid with a strong alkaline, then the heat of neutralization that we get will be higher. So if we use one strong and pair with another one weak, strong and weak, then the heat of neutralization, the value of the heat of neutralization will be lower. Strong 比较高 strong weak 其中一个 weak whatever 哪一个是 weak 都好了，你的 value 就比较低。Okay, so let's see what are the important experiments that you must go through first. So here, the first experiment I have chosen here is the strength of the substance, which is the strong and the strong weak type of question. Okay, because according to the list of apparatus and bacteria, the tips are okay. They sent out last time. There is CuO in the list, which can be a reactant to react with the acid for neutralization reaction. But some teachers say that the substance is being removed already or something. So we are not sure. We are not sure, but I still have to go through one time with you, just in case there is like a sudden change in the plan. So first, I'm going to go through the procedure with you all. Since your physics paper has already came out the unguided version, which wants you to write procedure, then I think most likely chemistry will be a guided one. I think okay, but it's still better if you can read through that procedure and remember it. It is not a lot, okay, just a bit only. They are quite easy. So when you are doing your experiment tomorrow, yeah, so there's one of this. Here is one thing you have to do. You have to, sorry, let me show you the English version. You will be given a small towel, rubber bands to wrap the beaker. So 你就要拿那个毛巾 or 拿那个布啊，包着你的 beaker. How do you wrap it? Let's say this is your beaker. Make sure, okay, you cover it like that. Okay, not just the side. Not like that. Not like that. The bottom also must cover. Okay, then you use the rubber band to tie it up. So the towel doesn't fall. Okay, so the next thing you're going to do is add solution into the beaker. Okay, so first solution go in, whichever solution according to the procedure. Hopefully it will be given. Let's say in my case here, I write 50 cm3 1.0 mol per dm3 of hydrochloric acid. The volume and concentration can be different. You just look at your apparatus carefully tomorrow and see what is the acid they give you. So I put it into I measured it in the measuring cylinder and then I poured it into the beaker. And then I measure the same volume and concentration of another solution, my alkaline solution, sodium hydroxide. And I pour it into another beaker. So there will be two different beakers. Okay. After that, we are going to take the initial temperature. You're going to put your thermometer in to the solution and take the initial temperature of both solutions. And then you record the initial temperature into the table given. Okay. So when you are taking this initial temperature, make sure all the substance has achieved a thermal equilibrium. So you have, when you're taking the reading, you spend longer time, okay? You spend like 1 to 2 minutes just looking at the reading, okay? Until there's no more changes, then only you record it down in the table. Okay, so let's say the value that I got for my sodium hydroxide solution is 27, then I write down 27. Okay. So after you record down everything ready, okay, you got this initial temperature, you got this initial temperature. The next thing you're going to do is you're going to mix them up quickly. Okay, you pour the solution from the normal beaker into the beaker that is wrapped with the towel or the cloth. And then you have to do it fast, do it fast, carefully. Okay, so make sure everything goes inside. And then, you are going to stir the mixture slowly with thermometer. Don't stir it too fast, slowly. Okay, because if you stir it very fast, like that, this can increase the heat loss to surrounding. 慢慢搅，冷静一点。Okay, then record the highest temperature of the mixture. So when you are doing the experiment, you have to keep on looking at your thermometer. You don't look at people around like, wow, how they do it, or wow, why the guy like that? Okay, you have to look at your thermometer, because when reaction happens, the neutralization reaction happens, the temperature is going to go up. So you are going to see an increase in the thermometer reading. Okay, let's say increase from 25, okay, 28, 30, then go up to 32, like that. Let's say lah. Keep on looking at the temperature until okay, it drops. Okay, let's say it goes up to 32 already, and then I started to see this thing go down. Like, okay, go down to 30, okay, maybe go down to 28. Then I only record down my highest temperature. Okay, what you can do is also you just look at your thermometer, and then let's say now it's like 28 already, then you write down somewhere in the paper, okay, now 28. Okay, then okay, now 29 already. Okay, 30. You just record it. Then so that you won't forget, like maybe after, like, sometimes people who are forgetful, they will forget the value. what is the highest value just now already? Okay, you can write down. Okay. So let's say the highest temperature it achieved just now was 32. Then I record it down. Like that in the table. Even. Okay. Then lastly, it depends on the experiment. If it is like this, strong and weak, they are going to ask you to repeat the steps by using something to replace the other one. So the example here I put is the weak acid. But let's say they really got the CuO, then the CuO will be used to replace the NaOH. But CuO is a powder. There's no way you can take the initial temperature of this CuO. So there will be no initial temperature for CuO. Let's say the experiment is HCl going to react with CuO. Then you just put the acid into the beaker, wrap with the towel ready. Then you put the CuO in, and then you stir it. So you just take the initial temperature of acid, and then straight away the highest temperature. Okay, just like that. So record everything down in the table given. Okay, read the table carefully. Okay, what they want. This is just a draft, okay? This is not Solan Bocho. You don't think that, okay, tomorrow it's going to come out the same table like this. Nobody knows. So when you are writing the reading, remember, for temperature, you must give one decimal place. If the temperature is 27, please write 27.0. And then please check your table and see whether units are given or not. 看一下它有没有给你单位。So if units is already given, then you don't have to write unit law. You just write the number. If unit is not given, then you have to write the unit yourself, Okay, like that. So you see what I do here is for all the solution, okay, you see sodium hydroxide, initial reading, the acid initial reading, and then there is this average temperature. Because the initial temperature, they can be different. Maybe this one is 26.8, then this one is maybe 27.2. Then you have to calculate the average initial temperature. How to calculate average? You plus the two initial value together. Then you divide 2. Okay. Then the highest temperature recorded minus the average, you get the temperature change, your theta. Then this is the second set of experiment, which you repeat it with different substance. Let's see. Here comes the variables. You can always get variables from the questions, okay? See what are the things, what are the materials that changes in the experiment. So in this case, for my experiment, it's going to be the type of acid. I use strong and weak acid. Of course, it can be strong and weak base. Easier answer, what you can do is like, if you doesn't want to write a type of acid, maybe you are not sure whether it's type of base or type of alkali, you can just write the name of the substance. Like in this experiment, I change the hydrochloric acid with ethanoic acid, right? Then I just write the name of the both acid. Hydrochloric acid and ethanoic acid. If it is CuO and NaOH, you just write copper 2 oxide and sodium hydroxide. So I'm teaching you the technique on how to get the answer tomorrow. Don't memorize blindly 不要死背你要看一下那个题目怎样走 and then 你去做一些应变。And then for responding variable will be like, what are you trying to get in this experiment? 你做这个实验为了什么？你要拿到什么？ So in this experiment, I'm trying to get the heat of neutralization. I want to know the heat of neutralization. That will be my responding variable. Okay, I'm trying to get the highest thermometer reading. That is the data I want to record. 这就是那个我做这个实验，我最重要就是要拿到这个 The most important data I want to get is the highest thermometer reading. Or you can also write it as, you can choose like, okay, whichever you want to write. There's another one which is highest temperature of mixture. That means after you mix the thing get together already, what is the highest temperature you can achieve? Okay, so responding variable is what are you trying to get from the experiment? Next, we have fixed variable, something that keep constant throughout the whole experiment. No change at all. Okay, so it depends on the experiment. So you have to try to look for the substance that doesn't change. Okay, let's say if the sodium hydroxide solution, the volume and concentration both are, if both also never change, then you must write volume and concentration. If volume and concentration doesn't change in the experiment, and you only write one of it, 就是你没有写到另外一个, you only write concentration, but you forgot to write volume, then you cannot get the mark. If both are the same, these two must come together. 在一起一定要一起写unless they are different lah. Okay. Then here, hypothesis. Hypothesis is making a smart guess. Like before you start doing the experiment, you already predict like, okay, what kind of result that I'm going to get. So like we know, before we even started the experiment, we know that the strong weak combination will be getting a lower heat of neutralization, right? So you see, that's why I write heat of neutralization between the strong. So heat of neutralization between the strong is higher than the heat of neutralization of the weak strong. Like that. Hypothesis. Okay, next. By the way, if you have any question, you can always text me, you can WhatsApp me, you can PM me, you can comment below lah, okay? So next, operational definition. Operational definition is telling people what we do in the experiment and then what is the result, what is the observation that I get. Okay, what you do, and then also what you observe. So what you do is like it's not the whole procedure lah, but the last step you do. After you do this step, you can immediately get result. 就是你一做这个步骤后，就有 result 出来了的。那一个步骤 the step, the only step. So the step I do here is the procedure. The things that I do here is I add the alkali solution in the acid. If it is hydrochloric acid, we write hydrochloric acid. Okay, depends on the question. So when I add the sodium hydroxide into the acid, then reaction will start, right? When reaction starts, what can I observe? Thermometer reading is going to increase. So the way of writing operation definition is we tell them what we observe first. Okay, thermometer reading increases when I do this. So this is what I observe. When I do this. And remember, you have to write thermometer reading increases. Don't write temperature increase. Reject this answer. Must be thermometer reading. Okay, next. It will be the calculation. So if they want you to calculate the heat of neutralization, it is the delta H, the triangle H. The question can also ask you to calculate. It's a different type of question. they can ask you to calculate heat energy release. So if they want you to calculate heat energy release means they only want the Q. Okay, be careful. There are two different types of questions. Okay, so if they want me to calculate heat energy release Q, it will be just Q equals to MC theta. When you're doing the Q equals to MC theta, remember M has to be the total volume of the mixture. 50 plus 50, according to my experiment, okay, 50 plus 50 times 4.2 times the temperature change you got from your experiment. Let's say mine is 6.7, I write 6.7. And then just press a calculator. And the answer will be 2814 joule. If they ask for heat release, that will be the answer, that's all. If they want heat of neutralization, then I got to do more steps. Okay, I got to do more. I have to calculate, okay, I got Q already. I have to calculate mole now. Mole of what? You have the volume and concentration of acid. You have the volume and concentration of the alkali. Then you must calculate the mole for both substances. So here I have to calculate the mole of HCl. I have to calculate the mole of NaOH. Both. So by using the formula mole equals to MV over 1000, I'm going to get 0.05 mole. And then the other one also the same. After you got the mole for both substances here already, remember to write, to show the ratio in the sentence form. Where can you get the ratio? Equation. If they doesn't ask you to write equation, you just write it out yourself. Then you can see the ratio is 1, 1, 1. The mole of the substance that we want to get here is water. So we are using HCl and NaOH to predict the mole of H2O. Okay, so here I just put in from the equation 1 mole of HCl, 1 mole of NaOH, I get 1 mole of water. So therefore 0.05, 0.05, I get back 0.05. So this is the mole of water that I want to get. So after I got Q, I got the mole of water. I just divide them. And I'm going to get negative 56.28 kilojoule per mole. Must have the negative sign and correct unit. Okay, so calculate Q, calculate mole, and then the delta H, heat of neutralization. So you read the question carefully, whether they want you to calculate the step 1. Okay, this is the step 1, the strong, or maybe they want you to calculate the step 2, strong, weak. Or maybe they want you to calculate the heat release for both experiments. Just like that. Now, moving on to the last part, observation, which we mentioned it just now. Thermometer reading increases. And the inference. Inference is to explain what you observe. You have to explain, you have to give one explanation. Hey, why the thermometer reading increase? Or because the reaction is exothermic. Like that. Okay. That's all for the first one. Now, the second question. Total got 4. The remaining questions now very fast one already because everything most likely the same. So question 2, is about how volume or concentration affects the heat energy release, or whether does it affect your heat of neutralization. Okay, so you see the procedure here is the same, totally the same as the one just now. The only thing I change is the last procedure. I repeat the experiment using a different volume of acid. So the first one I do is 50 cm3, and then I replace it with 30 cm3. It means I use lesser acid. Okay, so what's going to happen? First, I record all the reading. Okay, set one is the one that 50 cm3 one. Okay, I got everything, and then okay, change in temperature 6.7, theta is 6.7. When I use 30 cm3, oh, my theta is only 5. Why? Because lesser reactant, right? Lesser reactant, there will be lesser product produced. Whenever the product is lesser, the heat energy release is also lower. So manipulated variable. So in this question, you see the part that I repeat just now is using a different volume of acid. You just write volume of hydrochloric acid. Responding variables still the same. Heat of neutralization, or highest thermometer reading, or highest temperature of mixture. Exactly the same as the previous one. Only manipulated variable is different. Fixed variable also the same. Look at the question carefully and see what's the thing that keeps constant. Then hypothesis. The hypothesis for this experiment is slightly different. So what I write here is the higher the volume of hydrochloric acid, the higher the highest temperature of mixture, until all the sodium hydroxide solution are reacted completely. So meaning is, imagine okay, so let's say I start with my step 1 experiment where I only put, let's say, 10 cm3 of HCl. So the H plus will neutralize the OH minus. Reaction happens, release heat. Then no more H plus, right? Oh, then the heat release is just like that. Maybe like only 100 joule. So what is going to happen if I increase the volume of the acid? That means instead of putting 1, I put 3 now. Then there will be more reactants to react, right? You see, oh, react. So release heat, another 100 joule. This H plus react, oh, another 100 joule. So you see, the more volume of acid I put in, the more heat energy will be released. But until all the NaOH, all the OH has been neutralized already, and I further add more HCl, nothing is going to happen. No more OH minus to combine to form water. Okay, so the temperature change, the heat energy release will only increase until when all the NaOH is completely reacted. Okay, just like that. So this is why my answer is like that. Or there's another way to write the answer. As the volume of hydrochloric acid increases, the heat of neutralization remains the same. This one, it depends. If they want you to calculate heat of neutralization, the heat of neutralization will be the same. So please don't get confused here, Because you might think that, huh, why? I thought 1 H2O 100 joule, 2 H2O will be 200 joule different ma? How come you say the heat release is the same? Okay, see, imagine in the step 1, it only gets to produce 1 H2O, which is equals to 100 joule. Then if I repeat my step 2, I increase the volume of acid, I get more water, right? Then more heat energy. Yeah, this is heat energy. Q. So this is why just now when I start my in the beginning of the video, I said volume or concentration, they affect the Q, not the heat of neutralization. Now I explain to you why. Because you see, 1 water 100 joule, 2 water 200 joule. If I convert them to heat of neutralization, what is heat of neutralization? 1 mole. 1 mole. Let's say I convert it into 1 mole. So set 1, you see, let's say 1 is 1 mole, okay? Set 1, 1 mole, 100 joule. If set 2, 2 water is 200 joule, and if you convert it into 1, what happens? 2 to 1, then 200 will be to 100. They will be the same. Okay, that means it's still the same. It's still 1 water, 100 joule. 1 water, 100 joule. That is heat of neutralization. So that means doesn't matter you increase the volume or not, they are not going to increase the heat of neutralization, which is 1 mole. Okay. Observation and inference is the same. That's all. Operational definition, same. Calculation, same. It depends on the question. Whatever they give you, you just do it in the calculation. Be careful whether they want heat of neutralization or they want the heat energy release. Okay. Then the third set of experiment. Yeah, this is the one that I mentioned just now in the question 2. Change in volume or concentration. Just now was volume, right? And this one is concentration. No. Now, I repeat the experiment by using acid that has diluted with water. I dilute the acid is to get different concentration. Okay, is to get different concentration to replace the original acid. So you see, in case you don't know how to do dilution, you see, this is what they do. What I do. First step, I use 50 cm3 of the acid with the original concentration 1.0. And then to lower down the concentration, I add water. How do I do it? I think they are going to tell you lah. They tell you what to do. Your job is just to calculate the concentration maybe. So the formula for dilution is M1V1 equals to M2V2. So to find the new concentration, that means I have to find the M2 lah. So starting with the volume of solution of the acid is only 40 cm3. Original concentration is 1.0. And then we add 10 cm3 of water into the acid. So 40 plus 10 cm3 of water. M2, we get 0.8. Okay, that's how you do it. If they do it the other way around, if they give you the concentration and ask you how much distilled water to be added, what you do, okay, see, let's say the balik now, you got the final concentration 0.8, but you want to find out how much water to be added. V2 is equals to 50. You can try and press your calculator. Final volume is the volume of acid plus water, right? So if you only want to get water, you have to use 50 to minus off the 10 cm3 of water to get 40. Okay. And then just like that, okay, you have different concentration of acid, you just do the experiment, you record everything. Then variable, the manipulated one, you change it to concentration of acid. Then the rest of the thing here same. Hypothesis also almost the same, just change a word. Just now was volume. Now you change it to concentration. Okay, then observation and inference the same. Operational definition the same. Calculation the same. And last, okay, the last experiment here is I do not know lah. Okay, they can do something like this. They can first ask you to do the experiment without the towel, without wrapping the beaker, and then you repeat the experiment. Sorry, by wrapping it with the cloth or with the towel. So the one without the cloth will have more will have more heat loss to surrounding law. Okay, when there's more heat loss to surrounding, you get a lower value. So if there is a insulation layer, then there will be lesser heat loss to surrounding. So yeah, record your result, same thing. Variables, one got wrap, another don't have wrap. So presence of the wrap. Same thing. Hypothesis, the one with wrap is going to have a higher heat of neutralization. Than the one without wrap. Okay, because no wrap, more heat loss to surrounding, so lower value. Operational definition same, calculation the same. Okay, just like that. Okay, so most likely the question pattern will be something like this lah. Okay, hopefully they come out something easier than this. So good luck for your paper sheet. If you have any question, you can ask me. Yeah, bye bye. So I'm going to sleep now. Bye bye. See you next time.